All right, so we're going to read through the product rule, and you're going to agree, and if and when you don't, you're just going to say, where'd that come from, and we'll talk through the algebra. So I would highly encourage you not to, because you do have a printout of it, right? You do.
So we wanted to...
Should be adding some supplies. Some of that.
I'm not doing supplies right now. I'm sorry. I don't have them. I don't have them at my disposal.
I wasn't here.
All right, so we're going to step through. The first thing we do with the quotient is we use the limit of the difference quotient, right? So we're actually going to say that the derivative of f of x over g of x is going to be f of x plus h over g of x plus h minus f of x over g of x all over h. So we're using the definition of the derivative. This is a good standby when you can't do something algebraically to something. Go back to the definition of derivative to see if that helps. Okay, so next step. If you take this h and you multiply, instead of dividing by h, if you multiply top and bottom by 1 over h, right? I guess you could clear fractions where I think about dividing is the same as multiplying. You end up with f of x plus h over h times g of x plus h minus f of x, whoops, now it won't draw. Okay, minus f of x, it's gone on strike, minus f of x over h times g of x. So basically, I got nothing. Oh my goodness.
Am I ready?
Alright, that works. Alright, I'm trying my best here. What are you guys passing? Candy?
No, high five.
You are not.
Yeah,
Put the candy.
really should just give each other a high five. I don't know why I'm doing it right now, though. They were high fiving. Saying funny things.
Alright, I have one other idea. It's not going to work.
It was mischievous. Right on my part. I was very mischievous.
Mischievous?
Yeah, some kids drove.
Really? Really? Funny.
Yeah, and my name. They knew who I was.
Alright, I might have to go back. I'll go back to get the rest of it, but for right now. Okay, it's multiplying by 1 over h, so we have h in each of the denominators. Instead of dividing the whole thing, it's like simplifying a complex fraction. So far, so good?
Uh-huh.
Alright, so next question is, what did we do to go from here to here? What was that step? Yeah, we found a common denominator. Excellent. Very good. So Desiree would probably say we multiplied this by g of x plus h over g of x plus h, and we multiplied this by g of x over g of x. So our common denominator is h times g of x plus h. That's that piece right there. And in the numerator we get f of x plus h times g of x minus g of x plus h times f of x. So far, so good?
Yep.
Okay. Next step. This is the clever step. This is the step that you might not think of on your own. And that's to subtract f of x times g of x and add f of x times g of x. If we add and subtract the same thing,
They cancel out, but then
yeah.
you take something else. Like the product rule.
Yeah, exactly.
Bam.
So so here it is, right? We see this trick that we saw yesterday, and now you have that trick up your sleeve, Leah. You could do this proof. You don't have to, but you could, because you're developing tricks. Okay, so now if we look at the first two terms, what do we factor out of each of the first two terms? G of x. Then we look at the second two terms. What are we factoring out of the second two terms? Almost. No.
Negative f of x.
I think, aren't we doing... Oh, no, we're not. Yeah, we are. We totally are. Right? We're taking out a negative f of x, so we're left with g of x plus h minus g of x. Okay, so we're taking out a minus f of x.
I have a question about this before we continue.
Okay.
I have a question about this on the product rule when I was watching it. So, like, I don't know if this is right, and I could be totally wrong, but, like, when you do, like, the factoring by grouping, you know, how, like, you take the first two and then, like, the what's inside, like, how come they don't do that for these ones?
Say that again, because I don't understand the question.
I'll ask it, like, another time, because it's not good. It's going to confuse everyone.
Just try me one more time.
Yeah, when you do factoring by grouping, you take, like, one thing out that's, like, common.
Right, okay. These are not common in both.
Okay.
So if they were the same thing, if this was a g of x and this is a g of x, then I could take both of those out in front and I'd be left with this minus this. But that's the... So I think that's the key to why this is not factoring by grouping, because g of x and negative f of x are not the same.
Okay.
It's my guess.
But then don't you do, like, g of x minus f of x in, like, the first parentheses?
No.
Okay.
It has to be the same.
Okay.
These two have to be the same. Or what's inside has to be the same. One or the other. Okay. Neither is true.
Sorry.
No, it's fine. Okay, so now we take this apart. Here is the first term. That's this piece right here over that denominator. And then here is the second term, right? That's this piece right here over the common denominator. All right? All right, well, this is a total mess. So I have the g of x and g of x. I think what I'm going to do is I'm going to take this part and separate it. So this whole thing is what I originally had right here. Right? Those two are equivalent. Do you see what we did? Or not really?
Yeah.
We basically took f of x plus h over h, and then we took 1 over...
Why would you ever do that?
Because we're trying to prove something, right? And it's clever. And I'll tell you why. Why in the world would we want f of x plus h minus f of x all over h? That's the derivative. That's the quotient rule for... For what? No, for what function? F of x. So basically we're getting g of x, and here we're getting the derivative of f of x. And then over, man, what's this? Times 1 over, when h goes to 0, what's this become? Yeah, that just becomes g of x. So what's g of x times g of x? G of x quantity squared. All right, and then over here we get minus f of x. What's this thing? Times the derivative of g of x. And do you agree this is still becoming?
Yes.
All right, so I'm going to rewrite all this stuff, okay? I have g of x times the derivative of f of x over the function g squared minus f of x times the derivative of g of x over the function g squared. Do you see what I did? I took this and I took this and I multiplied across the tops and across the bottoms. Do I have a common denominator? I do, and I actually have my rule. My rule is this. The quotient rule says if you have a quotient of functions, take the function in the denominator, multiply it by the derivative of the function in the numerator, subtract the function in the numerator multiplied by the derivative of the function in the denominator all over the function in the denominator squared. Well, the quotient rule is a little less forgiving because there's a subtraction sign in it. So order is really important. You can't put the second term in front of the first. So, okay. An aid to remembering. You don't have to remember this way, but there are ways to remember. It's low d high. What do we mean by d? Derivative high. Minus high d low all over low squared. So if you need to memorize this trick, it's low d high minus high d low all over low squared. All right. It's a pattern. It's proven to you, but we really haven't seen the pattern work, and it would probably be to our advantage to do like 10 or 12 examples. Are you okay with the proving part? Like, some of you are really just happy with this, right? That's the box that's in your book, and certainly that's in the back of the book. The back flap of your book has that rule. With that said, you're convinced that I'm not lying to you, right? Okay, great. Let's do a million examples. What do I need to do?
Not extra out of that. Okay, you can.
Thanks.
Make sure you don't mix up low D high though when you say that. And
Yes.
say low D minus high.
Low d high minus high d low all over low squared. Let's see. I'd like to try this one two ways and try to convince you that we're going to get the same answer. And I'm slightly anxious because I'm not sure how difficult the algebra is going to be to get them to be able to show you that they're going to be the same. But I'm willing to try. Okay, so someone try the quotient rule, please. Should we do it together first?
No. I can low. X.
All right, low is x.
2x.
D high is 2x. Minus
X squared plus 3.
high is x squared plus 3, the quantity, times d low, times 1. Now, I probably wouldn't write that one, but for now I will. All over the denominator squared, or low squared, x squared. Is that an answer?
Yeah.
Certainly is. Do you have to simplify it? Certainly do not. All right. I'm feeling slightly compulsive, so I will. 2x squared minus x squared minus 3. Why minus 3? Okay. So I get x squared minus 3 all over x squared. That's the same as x squared over x squared minus 3 over x squared, which is the same as 1 minus 3 over x squared. All right? Did you have to simplify it like that?
No.
Absolutely not.
Is that how the book's going to do it?
Maybe. I'd actually like to do this a different way now. Let's do some algebra first. What's this function equal to? Like if I had to simplify it first before I took the derivative? Okay. X plus 3 over x? Okay. What's the derivative of x? Come on. Thank you. I was hoping more of you would say that. 3 over x, I'm mentally thinking is the same as 3 times x to the negative 1, right? Isn't that 3 times x to the negative 1? So that's going to be negative 3x to the negative 2. Hey, guess what's that's the same as? right? That's the same. Are we surprised? Not really. Is one easier than the other? I don't know. Yeah, ish. I don't know.
You stop at the first step of the quotient rule, then it's
Yeah, right. If all you want is, this answer, quotient rule is pretty easy to do. If you're looking for a simplified answer, probably doing some algebra first is better. And that's your decision to make. Questions, comments, concerns? Am I good now? How about now? And now?
yeah, you're good.
All right. Two. Um, all right. Who's up?
I'll do it.
Christina.
X squared,
Low.
high. Does it start with low? Low, yeah. Okay, 2x,
Low.
high d, so, so 2x.
D high.
Now, I'm starting with high now, so x squared,
High.
and then ln of 2 times 2x
D low.
over 2x, 2 to the x to the squared.
All right. And
Who knows?
you can write it as 2 to the x squared, or that's 2 to the 2x, because if you have an exponent to an exponent, the rule says that you multiply exponents. Okay? Okay? All right. Christina, call on someone.
Anyone? So low is 6 to the 8 times e to the x minus e to the x times ln to e. It's not e to the minus
Careful. I'm trying to trick you.
0.
Yeah. Right.
All over 2 to the 2 to the 2.
Oh, 2 to the 2e. Yep, 2e squared. Very good. Okay. This term goes to 0. 2 to the e over 2 to the 2e. If I wanted to simplify it, it would be e to the x over 2 to the e. And all that's to say is this is a constant times e to the x. The derivative of a constant times e to the x is a constant times e to the x. Right? So the quotient rule worked, and it agreed with it. You can think about it a different way and get the same answer in a different thought process. Is one better than the other? Absolutely not. Just different ways of thinking about it. That was good. Thanks for hanging tight with that, Lisa. Lisa, calling someone for... any questions on G of X? you see how that's tricky? That was the right answer. Thank you. Lisa, calling someone for H.
X squared plus 1
Low.
times 1 half x to the negative 1 half
D high.
minus x to the 1 half
High.
times 2x.
D low. I want to make sure that you understand how I'm being very cautious using parentheses. Like when I did low, I put x squared plus 1 in parentheses. I couldn't say x, if I didn't have those parentheses, it would be wrong. Like if I did every once in a while, I have someone do something like this. They just put the multiplication sign there, like x squared plus 1 times 1 half x to the negative 1 half. You have to show that it's the entire low times the d high. All right, finish it off, Caroline.
Over x squared plus 4 squared.
Perfect. Nicely done. Thank you. Questions on each of x? All right, Caroline, calling someone for I.
Okay, so you do cx plus d
Low.
times, make it d a
D high.
minus ax plus b
High.
times x.
D low.
Oh, sorry, d.
You know what? I knew exactly what you meant.
Okay, cool. Over cx plus d squared.
Okay. Good. How do you feel about that?
You forgot the derivative sign on the line.
Oh, thank you. Let's see. I think we're ready. Okay. Calling someone, Julia.
First question is, I'm going to have to use both rules, right?
This to me looks like the product of a function and a quotient.
So, I don't know which one to do first.
Could you just multiply
the
the 2 to
quotient
the x
first.
out? Could you just say 2x to the x times 3x?
If you want.
Well, I still have to do it.
Now you have the quotient of a product. So,
You can combine, you can't combine. No, you can't.
so as I see it, if this is the product of a function and a quotient, the product rule is the overarching rule. If this is the quotient of a product and a function, the quotient rule is the overarching rule. So I don't really care which one you want to use, Chris. You want to use it in the product form or the quotient form, and yes, you're going to have to use both rules.
I like the, let's try the product rule first.
Okay, so we're going to try keeping with the product. Okay. Go ahead.
Okay.
Don't mess up.
Thanks. So we're going to start with 2 to the x,
The first.
and then the derivative of the second.
Derivative of the second. Okay, so the derivative of the second is a quotient. We need to think about the derivative of the second. The derivative of the second is...
It's like the original function is technically 3x times quantity 5x plus 1 to the negative 1. Isn't it?
Oh. So you want to make this into a product?
Can I?
You can. I was hoping you weren't.
Oh. So should I then do the
Now we have to
quotient
do
of this?
I was hoping.
Okay, then I'll do the quotient of this.
Okay.
Which is going to be 5x plus 1
Low.
times 3
D high.
minus 3x
High.
times 5.
D low.
All over 5x plus 1.
Okay. So we have the first times the derivative of the second, but we're not finished yet. Plus
3x over 5 x plus 1.
The second.
And then it's just ln of 2 times 2 the x.
Derivative of the first. How's that?
I have a question. How many on the gateways are going to be like this?
Several.
Really?
Caroline. So, because it's a product, this is the first times the derivative of the second, and this is the second times the derivative of the first. Within doing that, we had a quotient, which we had to use the quotient rule for. We were giving each other high fives.
We were. That's
really
from advisory. I was
right.
just tired of having Swedish fish crinkle in my pocket.
So yeah, there's definitely going to be on the gateway a couple medium, a couple easy, a bunch of medium, and a couple hard. Believe it or not, it's a medium, and it's going to be like right now. No, listen. Right now, I'm sure it feels hard because we're using two rules that we just learned in the 2 days. In a week, those two rules are going to be like seem so simple, and so this is going to be. Okay.
You're trying to make us feel better.
I'm failing miserably.